Number 21, the mass percent of carbon in pure glucose, C6H12O6, is 40%. Okay. A chemist analyzed an impure sample of glucose, so there's something that really isn't supposed to be there, and determines that the mass percent of carbon is 38.2%. Okay, which of the following impurities could account for the low mass percent of carbon in the sample? Now, think about it this way. Mass percent is basically like grams of carbon over grams of the compound, which in this case C6H12O2, right? So apparently the fact that your mass percent is lower, well, we can say that in, well, two different ways. Either your numerator, aka the grams of carbon, is lower than what it's really supposed to be, aka you don't have as much carbon as you're supposed to, or the other way to explain it is maybe you have this glucose and then maybe you have something else, in this case the impurity that they're talking about, impurity, and therefore it's only increasing the overall, the total mass, but the grams of carbon is not going up. In other words, the impurity, whatever the hell that is, it probably doesn't contain any carbon. And if you look at the answer choices, it's probably going to be water, because take a look at all the other compounds in choices B, C, D. They all have carbon. Speaking of which, and especially choice C, I mean, it's literally the same goddamn compound. It's just an isomer, right? Glucose, fructose, galactose, like all these things are basically just the isomers of the same compound. So in terms of the actual mass percent, I mean, this thing is not even going to do anything. But the other ones, notice how it contains carbons. And especially for sucrose, it contains a significant amount of carbons in there. So if you were to toss in either ribose or sucrose, well, it's not going to necessarily drop the mass percent of carbon specifically by too much, because not only is the denominator going up, but your numerator is also going up. So it kind of offsets the effect if you guys see it from the mathematical standpoint, right? So for example, what I mean by that is if you have like 2/3, imagine I only, well, which is about like 0.66667, and imagine I only increase the denominator, so that'll be 2/4, and that's 0.5. It clearly goes down in its value, in its proportion. But if I increase the numerator and increase the denominator, in fact, this is actually 0.75, so it actually went up, right? So it just really depends, like whether your like numbers are big or small. So in this case, I'm just using like 2/3 to 3/4. But I mean, obviously, if you're talking about like 100/150 versus 101 versus 151, I mean, it's not going to be that much of a difference. But what I'm trying to tell you is, if both numerator and denominator go up, well, the effect kind of offsets. So I wouldn't be able to precisely guess whether the mass percent is going to go up or down. It just really depends on how big the numbers are. But if you were to toss in something like water, which has absolutely zero carbon, so your numerator is going up because you have more H2O there, but this right here, the grams of carbon staying the same, that means, well, denominator is only going up, aka your overall value, in this case the mass percent, has to be lower.